Okay guys, so mag-solve tayo ng mga problems for this topic. So basahin natin yung problem number 1. So determine the type of flow of water given the viscosity as 1 centipo flowing in a 50 millimeter diameter pipe at a velocity of 2.5 meter per second. So the required for this problem is to determine the type of flow. So before we can do that, we need to solve first for the value of its Reynolds number. So the given in this problem, so given dyan yung viscosity. So hindi natin alam kinematic o absolute viscosity ito. But the centipo is a unit of absolute viscosity or yung mu natin. So 1 centipo. So isulat na lang natin siya as 1 cp. Aside from that, given also is ang yung diameter ng ating pipe which is 50 millimeter diameter. So i-convert na natin to meter. So divide mo lang ng 1,000 to or that is equals lang to 0.05 meter diameter. And the pipe velocity, so yung V natin is given ng 2.5 meter per second. Okay, so solution. Ano nga yung equation natin for the Reynolds number? So kung maaalala yung tinuro ko sa inyo sa inyong lecture, so mas madali nyo siyang matatandaan if tatandaan nyo yung kanta ng magtanim ay d biro. So d v rho all over mu. Okay? So in-specify naman dyan kung anong type ng fluid yung dumadaloy. So that is water para malaman natin kung anong type ng rho yung gagamitin. So alam naman natin na ang rho for water is equals lang saan? Di ba equal siya sa 1,000 kg per cubic meter? Okay, so ilagay natin yung mga given. So this is 0.05. Hindi ko na guys isusulat yung unit times the velocity na 2.5 meter per second times rho. So that is 1,000 kilogram per cubic meter all over mu. So before that pala, we need to convert first this mu to its equivalent value in terms of Pascal. So ano ba yung conversion natin for mu? So yung centipo natin, dadali natin nga ito to Pascal seconds. Okay, so ano ba yung mga conversion natin in terms of POA? So first, in 1 POA guys, in 1 POA, there is equals to 100 centi-POA. And sa 1 Pascal seconds, in 1 Pascal seconds, there is 10 POA. So, ibig sabihin, yung 1 centipo natin is equivalent lang saan? So, unahin natin ito. So, we have in 1 POA, there is 100 centipo. And in 1 Pascal seconds, so there is an equivalent of 20 POA. So, cancel this one. Cancel. So, in terms of Pascal second, yung 1 centipo natin is equivalent lang saan? So, 1 divided by 1,000. So, that is 1 times 10 to the 3 Pascal seconds. Okay? So, after that, pwede na natin siyang ilagay dito, yung 1 times 10 to the 3 Pascal seconds, since alam natin yung Pascal is equivalent to Newton per meter squared. Okay, so masasatisfy natin yung unit. So maa-cancel yung mga units natin. And alam naman natin na yung Reynolds number is a unitless. Okay, so pindutin lang po natin sa ALQ. So sabay-sabay natin pindutin. So 0.05 times 2.5 times 1,000 divided by 1 times 10 to the negative 3. Or the answer is equivalent to 125,000. Pero hindi pa dito natatapos yung ating solution. So again, ang pinapahanap dito is ano ba daw yung type of flow ng water. So guys, since ito is greater than 4,000, therefore we can conclude that this type of flow is under the category of turbulent flow. So madali lang, di ba? So ano lang dito, take note of the conversions na lang for absolute viscosity. So, baka dun tayo madali. Okay, so i-search yung mga different conversion para at least kapag bigyan kayo ng kakaibang unit, so alam nyo kung paano siya i-convert to Pascal seconds. Okay, so let's proceed with the next problem. Okay guys, so for our problem number 2, so basahin natin yung problem. So a fluid having a viscosity of 2.39 times 10 to the negative 5 meters squared per second and specific gravity of 0.82 is flowing in a 50 millimeter diameter pipe, 120 meter long at a velocity of 0.69 meter per second. So we need to determine the following. So for letter A, determine the Reynolds number. B, for the friction factor. So yung F. C is the head loss due to pipe friction. And D, for the center line velocity. And last will be for the shearing stress of flow. Okay, so ano ba yung ating unang gagawin dito? So una, ilatag muna natin yung mga given. So ang given dito is na a meter squared per second. So yung viscosity na given dyan is in terms of kinematic viscosity or yung symbol na V, yung pinasosyal na V. So isulat natin muna yung mga given. So given yung kinematic viscosity which is equals to 2.39 times 10 to negative 5 meter squared per second. Also given is the specific gravity ng iyong fluid na dumadaloy dyan. So 0.82, most probably this is a type of oil. And next, given yung ating diameter, so most probably nominal diameter naman yung sinabi since walang ginigay na thickness. So 50 millimeter diameter. Guys, again, i-convert ko na siya directly to meter kasi in terms of meter naman lagi ang ginagamit natin for SI or in terms of feet for English. So this is, divide mo lang 1,000 or that is 0.05 meter diameter. Also given here is the length of the pipe which is equivalent to 120 meter long. And last will be the velocity of the fluid flow which is given as 0.69 meter per second. Okay, so first, let's solve first for the value of our Reynolds number. So again, ano nga yung equation natin for Reynolds number? So hindi na pwedeng gamitin yung D0, di ba? Kasi since ang given dito is kinematic viscosity, gagamitin natin yung isang variation ng equation niya. So for Reynolds number, the equation if kinematic viscosity yung given is equals siya sa V times the velocity over the kinematic viscosity. So since given naman lahat yan, directly substitute mo lang yan, 0.05 multiplied by the velocity na 0.69 all over kinematic viscosity na 2.39 times 10 to the negative 5. So kung mapapansin nyo, magiging meter squared per second yung taas kasi meter times meter per second and yung baba natin is na meter squared per second. So again, sabi nga, Reynolds number is a unitless value. So pindutin lang ulit natin sa ALQ. So sabay-sabay natin pindutin 0.05 times 0.69 then divided by 2.39 times 10 to the negative 5. So, ang napindot ko dito guys is 1,443.5146. So, since ito is less than 4,000, so this will be under the category of a laminar flow. Okay? Next, for letter B, ano ba yung sunod na pinapahanap natin? So, dito is yung friction factor, F. Okay? So, kung babalikan nyo yung formula, since this is a laminar flow, and di ba magkaiba yung formula for laminar and turbulent flow pagkuha dun sa friction factor. So, since this is a laminar flow, so di ba yung equation mo for friction factor is simply equals lang sa 64 divided by the Reynolds number. Okay, so yung sagot natin kanina. So kung maalam kayong gumamit ng store, maganda i-store nyo yung values niya. Ano? So kung titingnan nyo sa ALQ, that is just store, tapos pili ka na lang ng mga value, A, B, C, D, E, F, or pwede ring X or Y. So itago ko na lang siya sa value ng A. So, ito, naka-store siya sa letter A. So, ito, 64 all over Pero kung gusto nyo pindutin isa-isa, wala namang problema. 1443.5147. Pero ako, in-store ko siya sa A. So, pipindutin ko na lang is A. Para walang tapon, di ba? So, 64 divided by A. So, the value of the friction factor, so 0.0443. Okay? So, ayan yung sagot. So, yun lang natin ng underline. Okay, so since we're done with friction factor, let's proceed now with letter C. So, ang hinahanap naman dito is the head loss due to pipe friction. So, this is under the category of major head loss. Ano? So, ano nga ba yung equation natin for head loss? So, di ba, yung formula natin for head loss is equals lang sa friction factor multiplied by the length of the pipe all over T times the velocity head, or V squared all over 2G. So, substitute lang natin since I think nakuha na naman natin lahat. So, yung sagot pala natin dito, so it's either pindutin mo lang ulit sa calcu or ang gagawin ko, i-store ko siya sa value ng B. Ayan. So, isulat lang natin. So, ito is A multiplied by the length. So, friction factor. So, this is letter B. Ayan. Multiplied by the length of the pipe. So, 120 all over diameter of pipe na 0.05 times the velocity. So, 0.69. And then, naka-squared siya all over 2 times 9.81 or 19.62. Okay, so we will have the value for head loss. So, sabay-sabay natin pindutin. So, yung B mo times 120 times 0.69 squared divided by 0.05 divided by 19.62. So, ano napindot nyo, guys? So, napindot ko dito is 2.5821. So, ang unit natin will be in meter. Okay, so ito yung sagot for letter C. So, anong sunod nating pinapahanap dito? So, for letter D, ang pinapahanap na sunod is the center line velocity or yung B sub C. Pero yung B sub C mo, di ba doon sa ating previous video, yung average velocity kasi, ito kasi yung average velocity okay? Is equivalent lang saan? Di ba half lang siya ng center line velocity? So in short, to solve for BC, so BC is simply equals lang sa twice ng average velocity, or that will be 2 times 0.69. So B sub C is equals to 2 times 0.69. So that is 1.38. So that is meter per second. Dali lang na. And last, ano ba yung huling pinapanap? So for letter E, we need to solve for the shearing stress of flow. So yung shearing stress, again, dinenote sa symbol na tau sub O. So yung equation natin for tau sub O is equals lang saan? Di ba siya equals sa gamma multiplied by the head loss. So for this problem, that is yung H sub F natin. And then multiply by D all over 4 times the length of the pipe. So, nakalimutan ko palang i-store yung value ng sa head loss. Anyway, wala namang problema yun. Pindutin na lang natin. Okay, so ang una, yung gamma. So, since nag-flow sa atin dito, i-specify yung specific gravity. So, yung unit weight mo ng any fluid. So, equals lang yan sa specific gravity times the unit weight of the water. Okay? So, ang unit weight ng water natin, so, di ba yan ay equals lang sa 9.81 kilonewton per cubic meter. So, ang gusto mo, isagot mo is na newton per cubic meter or Pascal. So, yung gamma ng water mo in terms of newton per cubic meter, so, multiply mo lang ng 1,000 or that will be 9810 newton per cubic meter. So, gawin ko na lang in terms of kilopascal para 9.81 yung gagamitin ko. So again, specific gravity, yung 0.82, multiply by the unit weight of water na 9.81, times yung head loss natin. So hindi ko nga ito na-store, iyan ako na lang, sulat ko na lang dito. 5821. So maganda guys, ini-store nyo, no, para masanay din kayo and para walang tapon yung inyong sagot. When I say tapon, yung though 4 na decimal to, medyo accurate na yan kasi maraming decimal yan compare sa 2 decimal. Iba pa rin yung na-store yung value kasi yun yung exact na sagot. So times the diameter na 0.05 all over 4 times the length of pipe na 120. So what will be the answer? So again, the answer will be in kilopascal. So pindutin ulit natin 0.82 times 9.81 times 2.5821 times 0.05 divided by 4 divided by 120. So ang sagot ko dito, so is maliit nga, no? Is 2.1636 times 10 to the negative 3. So kaya siguro ang ginamit sa libro is yung Newton per cubic meter kasi maliit nga yung magiging sagot. So i-times ko ng 1,000 para naka-Pascal siya. Or 2.1636 Pascal. Okay, so any of these two answer is acceptable. Ayan. So, ayan. So, we're done with problem number 2. So, let's proceed with the next problem. Okay guys, so for our third problem, so basahin natin. So determine the friction factor from the given data. So given is the Reynolds number, which is equivalent to 20,000. We have D, which is equals to 50 mm, and the roughness epsilon with the value of 0.5 mm. Okay, so kung maaalala doon sa lecture natin, itong roughness epsilon na to, kasi ito yung pinaka gaspang ng surface do sa loob ng iyong pipe. Kung naaalala, ito yung minagnify ko do sa figure. So, ipakita na nga natin. Ayan. So, ito nga is usually sobrang liit. So, kapag in-enlarge mo siya, ayan yung epsilon na tinatawag. Okay, so, burahin ko lang ulit. Hindi naman siya kailangan. Pinakita ko lang. Alright, so ngayon, hahanapin natin yung friction factor dito. So the required is the friction factor F. So required. Okay, so dito sa problem na to, we need to classify first if ano yung classification ng magiging type of blow nito. So, kung maaalala, when the value of the Reynolds number is greater than 4,000, therefore, this can be considered as turbulent. Turbulent. Kasi nga meron siyang kanyang formula for a turbulent and laminar flow. And since binigay yung kanyang roughness, which is 0.5, so ang gagamitin nating formula is yung kay Colebrook equation. Okay, so pa-browse na lang kung ano ba yung Colebrook equation. Pero ito is na-discuss natin from our last discussion. Okay, so using the Colebrook equation, so pa-check naman doon sa inyong notes. So ano nga yung ating equation? So that is, hindi ko na isusulat yung mga given na ano naman dito. So that is 1 over square root of F is equals to negative 2 times the logarithm of the quantity of the roughness over the diameter, then over 3.7 plus 2.51 over the Reynolds number times the square root of F. Ayan. So actually guys, this is just a direct substitution. Ano, ang nangyayari lang talaga is i-shift solve mo. Okay? So, ang gusto lang din kasi natin dito is 'di ba may binigay kaming table? So sa table na yan, i-check natin if pareho lang ba ng lalabas na sagot. Okay, so i-substitute natin yung mga values dito sa equation na to. So 1 over square root of f, so ito nga yung unknown, so negative 2 of the logarithm of the roughness height, so epsilon 0.5 over the diameter of the pipe. So maka-cancel naman to. So hindi ko na siya need i-convert, no? So kasi mm by mm, so that is cancel. Over 50 over 3.7 plus 2.51 of the Reynolds number na 20,000 times the square root of f. So input nyo lang sa ALQ, guys. So 1 divided by square root of f. So ilalat ko siyang x is equals to the negative 2 times the logarithm of the quantity na 0.5 divided by 50 over 3.7 plus 2.51 over 20,000 times the square root of f. So x. Ayan. So sheet solve. So hihingan ka dito, guys, ng value ng x. So ang gawin natin, positive value. So okay, so anong napindot nyo, guys? So ang napindot ko is 0.0407. Okay. So this times, guys, ang gagawin natin is gagamitin natin yung chart na pinakita yung table. So again, ang tawag nga dito is yung Moody chart. So ang gagawin nyo lang dito sa Moody chart na to. So i-check natin, ha. So yung nakuha nating sagot using the equation is 0.0407. So dapat kasi pareho lang din ang lalabas na sagot dito or malapit yung sagot na maupuhan natin using the Moody chart. So paano ba gumamit na itong Moody chart? So madali lang yan. So guys, dito sa y-axis mo, itong relative roughness, so that is just the ratio of K over D, or ito yung roughness height over the diameter, or itong part ng equation na to. Okay? So, tingnan lang natin yung numerical value niya. So, roughness height over the diameter is 0.5 over 50, or that is equals lang sa 0.01. So, ang ibig sabihin, dito sa curve na to, ang i-consider natin is ito. Okay? Itong line na to. Ayan. So, dito tayo magre-refer sa value nito. Okay? So, burahin ko lang kasi ito nga yung ating gagamitin. So, lagyan ko na lang dito ng check mark. Next, on the x-axis, so dyan naman si Reynolds number. So, from our given, that is 20,000. So, kung titingnan nyo dito sa gauge natin, etong first number na nakasulat dyan is 10 raised to 3, or that is equals to 1,000. So, yung sumunod, 2,000, 3,000, 4,000, 5,000. And the next to that, that is the range for 10 raised to 4 or 10,000. So, again, ang given sa atin is 20,000. So, ang ibig sabihin, itong line na to, ito yung gagamitin natin. Okay? Pro-project nyo lang yan hanggang lumapat tayo doon sa line ng or curve para sa 0.01 for the ratio of the relative roughness. So, ito yung gagamitin natin. So, i-project nyo lang. Alin nga ba line yung ginamit dito? So, ito. Ayan. So, kung saan sila mag-coincide dito sa point na to, ayan. So, yan, tumapat na yan. I-project niya siya dito sa value ng coefficient of friction. Dito sa leftmost end. So, yan ko lang dito. So, ito yung dito nag-coincide yung sa x and y axis. Then, next step, i-plot nyo lang siya dito. Ayan. Okay. So, as you can see, guys, it is between the 0.04 and 0.05. So, syempre, yung value mo is before pa naman siya magkalahati. So, di ba, itong value dito is 0.045. So, less than this value. So, kung makikita nyo, medyo malapit tayo dito kasi yung na-highlight nating portion is andito banda. Kalilipay ko pa. So, pag accurate kasi ng pagka-graph nyo guys is paglapit ng sagot natin doon sa gamit yung equation niya. So, maganda dito guys, may ruler. Hindi ko lang kasi maano. Ayan. So, I think medyo mas lumapit nung isinum ko. So, sa tingin ko, sa reading ko dito, yan ay nasa 0.04069 ba yun? O 4? 4 tapos 2. Ay, mali. Ano pala to? 5 to. 5. Linaw na mata, no? Nabasa ko yung ganong reading. Okay, so makikita nyo. Binibiro ko lang. Kung makikita nyo, medyo malapit yung ano. So guys, dito na, ang nakasalang-alang dito kung gaano kayo ka-accurate mag-graph. So, pinaita ko lang na dapat magkalapit lang yung sagot. Pero kung ako sa inyo, ito lang yung gamitin natin na ano. May equation naman eh. Ano? So, ganyan lang gumamit ng Moody chart. Okay? So, let's proceed with the next problem.